Hi, my name is Armando Diaz, and I'm gonna be talking about a paper titled Open Source Machine Learning Software Systems Architectural Analysis. This paper was published in 2021. The content of this paper is structured as follows. So we have an introduction section where we talk about why machine learning is important. We also explain some concepts. We have the body section where we talk about the methodology, experimental results, systems comparisons, and finally, the future work. Introduction. Machine learning. So why is machine learning so important? So basically, machine learning has accelerated the development of many fields. Some of them are manufacturing, healthcare, insurance, customer service, transportation, and so on. So how it works? So basically, machine learning works with a lot of data, and based on this data, we can use like very complex algorithms to model data patterns that can help us understand the relationship between many data points that are in multidimensional spaces. So basically, it can be really complex, and it can solve like very problems about optimization, and also problems regarding um, marketing or any other field. So we use these machine learning models to understand more certain industry, and we can use that information to get insights that maybe are not very intuitive or very easy to see at the first time. So some of the concepts that this paper study is the definition of software architecture recovery. Basically, this is a technique that help us to understand the structural characteristics and layout of the software. So this technique has two different approaches. The first one is the parent-based. The second one is the cluster-based. And this technique is fit from the source code or user knowledge or any other architecture artifact that can be found from the platform. This is a very high diagram where we can see how it works. We have also the definition of MLM framework. So basically, an ML framework enable developers to select, pre-build models, and optimize components, which usually help in the model building. So this paper in particular is focused on 4 frameworks, and these are displayed here in this slide, where we can see the TensorFlow, Caffe, MXNet, and Microsoft Cognitive Toolkit. These different frameworks, some of them are bigger than others, some of them are older than others, or have more contributors than others. But the main thing about them is that they are open source, so we can use a tool or a special tool to extract information from the source code to understand and study the architecture of these frameworks. So why is so important to study the architecture of machine learning frameworks? This is important because we wanna, since these frameworks are used to build and develop many applications in a lot of industries, we want to make sure that these frameworks are following the best practices, and also that they don't have security risk. So we want to make sure that we can mitigate them, that we can avoid them, that we can just make them secure and scalable. That's the main purpose. So for the body section, the methodology used to extract information from these ML frameworks was the use of Star UML. So this tool help the authors to extract the UML class diagram, package diagram, that help us to gather information about the structural characteristics of the most famous systems, and also recollect like some metrics that can help us understand if some of these frameworks are very complex or are if they have some vulnerabilities too. The experimental results. So as I already mentioned, the goal is to understand and study the architecture of machine learning frameworks, and in order to study them, the authors propose 4 different metrics, and these are complexity, size, coupling, and cohesion. So the complexity contains mostly characteristics such as the number of links, number of types of communication mechanism, and also number of children that help us to understand how deep in the architectural hierarchy is in this framework. We also have the size that tell us the number of connectors, number of components, number of processing units, number of persistent components. The coupling. This here we measure the number of dependencies mostly. Also, if we have external interfaces, so we have internal interfaces. In the cohesion, we study how many local methods we have in our framework. TensorFlow. So these are the results for TensorFlow. As we can see here, we have the complexity. In the complexity part or metric, we have 27 lengths. We have 118 children, and also we have 544 local methods. So if we just see these numbers, we can see that just in general, this framework is kind of complex and kind of not super big, but is kind of big. Is telling us that well, we have a lot of methods, but also we have 16 number of associations per class, which is not a lot of coupling, but the complexity is still high. We have here the Microsoft Cognitive Toolkit. As we can see here, we don't have a lot of links, but we have like 16 connectors, which is good. This tells us that at least this framework can be used in different in different cases. We also have 494 children, which is a lot. As we compare here with TensorFlow, we have even more here, and also we have more local methods. It's just a lot of local methods compared to TensorFlow, but we still have 16 association number of coupling per class. So if we just see the difference between these two, we can see that Microsoft can be harder to maintain because it has just a lot of classes, just the same number of it has a lot of methods and the same number of classes, which is it can be concerning for maintainability in the future. We have Cafe. For this framework doesn't have a lot. It has 0, 0, 0 in the complexity. It has 11 connectors, which is good. But it only has 19 local methods, and it doesn't have any class association of classes. So we see that Cafe is a is probably the smallest framework of these three. The complexity is not like very high, but also maybe there are not like a lot of contributors who are working in this project, so that's probably why. We have also the MXNet, and this one has 185 local methods. This is like 67 children, also 6 in the association per class. So if we see this one will be like in the middle. Maybe this one is like this is the one that has like more of everything. But this one is like this one is a little bit better, less, a little bit more maintainable, I would say. And also we have here a summary. In this summary, we are just comparing these four frameworks, and we can see just the versions that were analyzed, the number of classes for each framework, and also how many lines of code we have for each framework. So we can see here that TensorFlow is the winner here. It has like over 4,000 lines of code. And finally, we also see just the comparison of the metrics between the four frameworks. So we can see here that just the number of connectors, the winner is TensorFlow. Is the biggest one, the most popular one, which makes sense. Number of children is Microsoft Cognitive. So this is like, no, yes, is Microsoft Cognitive, which is telling us that the hierarchy in the architecture is just higher. And also this one has the most number of local methods. For the association per class, we can see the Cafe is just the smallest one. For future work, the authors mentioned that they want to look for more metrics that can help the analysis, and also they want to use other type of tools that can help to extract different characteristics regarding architectural analysis. So basically that's what they want to be working on. And some of the references, and that's it. Thank you.